Parts of a word problem. That's what our lesson is going to be on today. Word problems are problems made up of words. And we need to figure out the numbers and the equations that are needed to answer those problems and figure out what the solution is. So we're going to watch, we talked a little bit about variables yesterday and what variables are. Variables are when we don't know something. We use like an X or a box or a line. And we talked about how like younger grades use different things like the boxes and the lines, and now as we get into these older and more grown-up grades, we get to use letters and symbols. So we already talked about that, and that's still going to be being used today. Just because we talk about it does not mean it goes away. It keeps building upon each other, all right? So today we're going to watch this video, and we're going to learn about what an equation actually is. You will also learn how to use a variable or a letter or a symbol to represent an unknown number, which we did learn a little bit about before, but they're going to reiterate it because it is still very important, okay? We're going to watch this video. It's only about 4 minutes. At the end, I will summarize it a little bit, and then we'll keep moving on, okay? Again, any questions during that video, my video, any of these videos inside videos, it's crazy. Pause it, ask a question. I'm always here, okay?
And today I'll be helping you out with problems involving equations with variables. Okay, so let's first review the definition of an equation. An equation is a number sentence showing that two amounts are equal. So what we're going to be doing here are writing equations from some words that are given to us. So for example, an example of an equation would be like 3 plus y equals 5. Okay, because we have this amount on this side and this amount on this side would both be considered equal, the 3 plus y and the 5. So let's take a look at this example here and see if we can write an equation. It says 3 boxes of crayons with an equal number in each box is a total of 15 crayons. Now let me give you a little hint here. If you have is going to mean equals. So that's where you're going to put your equal sign. So 3 boxes of crayons, so we have 3 boxes with an equal number in each box. So we don't know how much that is, but we know we're multiplying 3 times, and the reason why we're multiplying is because we have 3 boxes times the number of crayons in each box will give us the total of 15.
The words here that tell us that we know we're multiplying is each. If you see each, it has to be a multiplication problem, okay? 3 boxes of crayons with an equal number, so it means same number, in each box. Each always means you multiply, okay? You're not going to do anything else but multiply. It has to be a multiplication problem when you see each. I know it doesn't say times in here, and it gets a little confusing, but each means multiply, okay? Sorry, I'll let her keep teaching you now.
So 3 times, let's call it C, is, so that's where we put our equal sign, a total of 15 crayons. So all we're really doing with these is translating the words into numbers. Okay, and again, remember your is going to mean equals. Finally, with these, we're going to be choosing variables, and remember, a variable is a letter or symbol representing an unknown number. So in this case, we chose C as our variable because we're talking about crayons, and our variable represents our unknown number, the equal number that are in each box. Okay, good. So let's take a look at another example here. It says, create an equation for the situation below. Choose a variable and tell what it represents. All right, so our problem here says we have 4 cans of tennis balls with 3 balls in each can is the total number of tennis balls. So which one of these equations best represents the situation? Is it A, 4 plus 3 equals B, B, 4 times 3 equals B, C, 4 minus 3 equals B, or D, 4 times B equals 3? Excellent job. You should have said B, 4 times 3 equals B, because it says we have 4 cans of tennis balls, so we know we're going to be using 4 with 3 balls in each can. So 4 cans times 3 in each can is the total number of tennis balls, which we call B. So again, in this case, the variable was kind of chosen for us because we had to choose from one of these equations. But our variable we we're given, I guess, would be B, and it represents the total number of tennis balls altogether. Okay, good. So let's take a look at one more example here. It says, create an equation for the situation below. Choose a variable and tell what it represents. Okay, so again, we have a situation where it says, a number of books divided equally among 7 shelves is 8 books on each shelf. Go ahead and create an equation for that and click continue when you're ready to check your answer. Excellent job. So a number of books is what we're looking for. So let's call that B. Divided equally among 7 shelves. So divided by 7 is, that means our equal sign, 8 books on each shelf. So B is our variable and it represents the number of books started with. So number of books started with, I guess I would say. Okay, good. Great job with equations with variables. Remember, you're going to translate your words into numbers and use a variable to represent your unknown number.
You might have noticed you didn't solve anything. There's no point in doing math if you're not going to find the answer. This is the first step. We do need to use the variables and we need to be able to write our equations from the problems. But you also need to solve it, guys. Alright? So you only went halfway. Make sure you're solving things. And if you're like, Ms. Farmer, I don't know division. Division is just multiplication backwards. So switch things around a little bit and you got a multiplication problem. 8 times 7 equals whatever B is. Switch it. We'll deal with that later though. That's not super important for right now, and I think that's why she didn't solve it, because right now we're looking at how to make this into an equation. Now that you've seen unknown or variables in basic equations, you can learn how to find them in word problems, okay? Every word problem has known, things you know, and unknowns, or things you don't know. Can you find the knowns and unknown in this word problem? Let's go over this one together. I'm going to scroll up because we're going to need some of this. Also, some of the answers are already down here. Joe is 12 years old. His little sister Jamie is only 2 years old. How many times older than Jamie is Joe? Okay, so first off, what's the first thing we know? The very, very, very first thing we know without any question is that Joe is 12 years old. It told us right here. Joe is 12 years old. No questions about it. Joe is 12, okay? So we got Joe equals 12 years old. What else do we know? His little sister Jamie is only 2 years old. All right, well, we know that his sister is 2 years old. Jamie, how did this spell Jamie? Jamie is 2 years old. So these are our knowns, right? This is what we know. What is our unknown? What is our question mark? What is our variable? All right? We're going to put them over here so they're very separated. Our unknown, our question mark, our variable, I think down here they're going to use y, so I'll just put y there, is how many times older than Jamie is Joe. So our unknown is the multiplier. Our unknown is what's the difference. It's how many times older. So we first identified our knowns and our unknowns. The word older means you're comparing ages, because when you see something like ER, it's normally a comparison. ER, EST, older, oldest, you want to compare different ages. We're comparing. So we're going back a few lessons to when we did that, and we're comparing using multiplication, right? The part that is missing is the multiplier, or how many times older Joe is than Jamie. So when we go to write this as a multiplication sentence, we know that Joe is 12, right? That's the answer. That's how many times older he is. That's not how many times older he is. That's the answer. That's how old he is. So we got Jamie's age of 2. Jamie's 2, right? We know that Jamie is 2 years old. Joe is 12 years old. and something in here is gonna get us to that. So we're gonna multiply it, remember we use the dot instead of the x because we don't wanna mess up our variables, by the years old, okay? So Jamie's 2, Joe is blank times older, but he's 12 years old, okay? So these are how many years of difference, how many times older than Joe, okay? Look at that, we got the same thing going down here. Now we have the equation 2 times y equals 12. When you solve for the unknown, you know Joe is 6 times Jamie's age. How do we know that? Well, we can do this a few different ways, okay? The best way to do it is putting missing things. 2 times 1, is that going to equal 12? No. 2 times 2? No. 2 times 3? 2 times 4? 2 times 5? 2 times 6? That does equal 12. As we keep going, these are going to get harder and they're going to be higher numbers and more difficult. But for this one, guess and check like that is a fine strategy, alright? Going, okay, well, what times 2 is going to equal 12? 2 times what equals 12? We'll talk about different ways to do it in a little bit that are more complicated, but I don't want to confuse you right now, okay? Because right now we're just trying to figure out the unknown, put it into an equation. So the correct answer is 6. Alright, Joe is 6 times older than Jamie, because we would find that 2 times 6 is equal to 12. Alright, let's go to the next slide. Ms. Farmer might have to erase some things. Yes, definitely gonna have to erase some things. Goodbye, Joe and Jamie. Alright. How do you use math to compare two things? Some problems have 2 sets of numbers. One set is often a multiple of the other set. Often the multiplier is the part that is unknown. These types of problems are called multiplier unknown comparisons. Whoa, that was a lot. You have 2 numbers when you're multiplying things. One of them is normally unknown. You normally have one multiplier and you have the answer and you have to figure out what goes in the middle there. That's what this is saying and all of that mumbo jumbo. Alright. The multiplier tells you how many times there are one set of numbers. And that's what we're doing here. Okay, this is the most important part on the screen. Can somebody, I guess, not read it for me because you guys are all at home, so I'll read it, but please read it along with me. To solve the problem, you need to use the opposite of multiplication, which is division. So when we were talking about Joe and Jamie, we had this equation up here. We had 2 times y equaled 12. And I told you we could do guess and check, and we could do 2 times 1, 2 times 2, 2 times 3, 2 times, until we got to 2 times 6, which equaled 12. We already know that the answer is 6, which is why I'm putting this one up here to use. A different way we could do this is we could convert the equation and we can change it, alright? We can change it into a division problem in order to solve it, because sometimes that's going to be what we have to do. So if I know my equation is 2 times something equals 12. 2 times something equaling 12 is the same as 12 divided by 2 equaling that something. It's going to equal the same something, alright? The reason I can do this, the reason this works, is because multiplication and division go back and forth. They are opposites. Just like addition and subtraction, okay? Think about back in school when you were in like 1st and 2nd grade, maybe even 3rd grade, and you did things like this, and you had 4 plus 6 equals 10, right? You could also have 10 minus 4 equals 6, or 10 minus 6 equals 4. And I guess I should have done the other addition one too. 6 plus 4 equals 10. Because those are your fact families, right? They all go together. They can go back and forth like that. Multiplication and division work the same way. They go back and forth. So if I had y times 2 equals 12, I could also have, oh, I'm sorry, I read that backwards anyways. If I had 2 times y equals 12, I could also have y times, oopsies, 2 equals 12. It's the same thing. Which means I can take those 12s and divide it by 2. And I can have 12 divided by 2 equals y. Or I could even have 12 divided by y equals 2. It's a fact family even though we don't know that one fact. Even though that's a variable, it still works the same way, which is why we're able to do this. If you're getting really, really confused, don't forget to stop and pause. I'm right here on Zoom. You can ask me anything. My Zoom is actually still up in the corner. I always make sure I have it just in case you need it. Okay? Alright. Moving on. Alright. We're going to solve these problems together. Because when we're finished with this, I'm going to send you back to your seesaw activity where you're going to do some more practice problems before you complete your accelerated quiz. Okay? So, the plane travels 600 miles per hour. The car travels 50 miles per hour. How many times faster is the plane than the car? So the first number set is 600. The second number set is 50. The unknown is how many times faster the plane is than the car. Wow, it wants us to solve it. So let's first write the equation. Is 600 going to be a multiplier or the answer of how fast the plane is? Good, it's the answer of how fast the plane is, which is like our total number, the fastest number. When we're comparing two things, we use the smaller one, we multiply it by something, and then the bigger answer, the other comparative part, is what it is supposed to equal. Alright, so we have 600 miles per hour, mph, miles per hour, that's what my label's going to be on that, is equal to 50 miles per hour times something. We'll use, what variable do you guys want to use? Let's use, let's just use x. X is kind of a catch-all. We'll just use x right now. So 50 miles per hour times something is going to give us 600 miles per hour. Those are big numbers. Those are big numbers that you might not have worked with before. So let's look at our options and see like what numbers they give us that we could try to plug in for x to see if there's an answer, right? Because if it's multiple choice, one of these has got to be right. There's different ways you could do this. You could guess and check. 50 times 1, nope, that's only 50. 50 times 2, 50, 100, nope, that's only 100. So we could do guess and check. That might take us a little while. But right here, they give us 1, 2, 3, 4, 5 options. So instead of guessing all these different options, we can just test 5. Test the options that were given to you and see if they're right. For multiple choice, this is a really good strategy, guys. So this first one says the plane is 6 times faster than the car. This one says the plane is 5 times faster than the car. The plane is 10 times faster than the car. The plane is 12 times faster than the car. Or the plane is 14 times faster than the car. Let's put these numbers in and test it out, okay? If our x, if our times faster was 6, let's see. 50, 100, 150, 200, 250, 300. Did 6 work? No. Alright, 6 was not the answer. Forget about it. So that one cannot be right. A is wrong. Guys, we just did 6. Was 5 right? If 6 was too small, was 5 right? No. You don't even have to redo it. You can if you want. 50, 100, 150, 200, 250. But you don't even have to do that because you already knew that 6 was too small. So 5 was definitely too small. Look at that. Done. 2 options down. All right, let's do 10. All right, I'll put my marker down. 50, 100, 150, 200, 250, 300, 350, 400, 450, 500. That equals 600? No, it did not. So guess what? 10 is incorrect. It can't be 10, it's not big enough. It's not 10 times. So far 6 is out, 5 is out, 10 is out. We're up to 12. Let's try 12. If you remember where we were just at 10, which equaled 500, and would be a great place to start this next round. So you would already be like 10, 50, 10 times was 500, 550, 600. What's 10 plus 2 more? Guys, 12. Did 12 give us 600? Because we had 50, 100, 150, 200, 250, 300, 350, 400, 450, 500, 550, 60. Oh, 600. Not 60. 600. Like that. 12 worked. So right now, I'm like, woohoo! 12 is totally the answer! But when you have multiple choice, it's always good to double check. So then we're going to be like, okay, let's just double check that 14 doesn't work. We were at 500, 550, 600, 650, 700. 700 is too big. 14 cannot be the answer, but I just wanted to double check it and make sure that I wasn't going crazy. The answer to this problem is D. The plane is 12 times faster than the car. You guys see how we did that? We wrote the equation, we worked through the problem, found the answer. All right, I'm going to erase and we're going to do another one. Just like I can say, oh wait, oh, no, I hit the wrong button. I'm sorry. Go back. So 12 was the answer. Let's see if we're right. We can click on it. Yay! The equation is 50 times something equals 600, where the S is the number of times faster the plane is than the car, and 12 is the answer. Let's go to the next question. Derek is 37 inches tall. His brother Bob is 74 inches tall. How many times taller is Bob than Derek? Guys, what was the big number? What's the answer here? The answer here is 74, right? That's the big number. That's the taller, so that's going to be the equal. So 74 is the bigger. Derek is the smaller at 37. We don't know the multiplier. How many times, but we know it's going to be multiplying because it says how many times taller is Bob. And let's put, don't use the X, right? Because that looks like the variable. We use the dot, and I'm going to put a T for taller, times taller. I don't know, seems like it works. Remember, you can use anything as a variable, except for O. We don't use O because it looks like a 0. The first number is 37. The second number is 74. The unknown is how many times taller Bob is than Derek. Yep, we did that. We did that together. They told us it, but we did it first. Bob is the same height as Derek. No. I think right off the bat we can answer that and say that's not right. If one's 37 inches and one's 74 inches, they're definitely not the same height. Those are different numbers. So right away I'm going to be like, nope, that's wrong, right? Bob is half as tall as Derek. Well, Bob is 74 inches and Derek is 37 inches. I don't think Bob is half of Derek. I think that's definitely wrong, right? Bob is not shorter than Derek. So that one we can cancel right away. Bob is twice as tall as Derek. Bob is twice as tall as Derek. Maybe. We'll go back to that one. Bob is 3 times as tall as Derek. Maybe. Or Bob is 4 times as tall as Derek. Maybe. These ones get to multiplication and get to things that we can do. Twice. It doesn't say a number. What is twice? 2 times. Twice. You have to do it twice. You have to do it 2 times. okay? Twice is a little tricky because on these two it says 3 times, 4 times, but twice doesn't say 2 times, it says twice. That happens sometimes. Be wary. Watch for that. So let's use our multiplication and see what we can do. And if you're like, Miss Farmer, I don't know how to count by 37s. Yeah, nobody does. It's okay. Counting by 37s is insane. That's not something people do on a normal basis. But remember that multiplication is also repeated addition. So we can just repeatedly add things. So if we want to try twice as tall, and that would make our equation 37 times 2 equals 74. Let's try that. But I'm going to come over here and I'm going to do 37 2 times. Because we're not multiplying 37 by 2 because we can't count by 37s, and that's not something you should know off the top of your head. Well, 7 plus 7 equals 14. 3 plus 3 is 6, plus 1 equals 7. Wow! Guys, I think I got the right answer. But should we trust this, or should we check these other two? You're right, let's check these other two. Let's say, what if I did 37, Bob's height, 3 times? So if I did 37 plus 37 plus 37, well, it's 14, 21, 3, 6, 9, plus 2 more. That's too many, right? That's way too big. He'd be a giant if he was that big. And so if that was too many, I think 4 times is definitely going to be too many. And we had already found that twice was the perfect number. So our answer is Bob is twice as tall as Derek. Bob is 2 times taller than Derek. Okay? Check our answer, see if we're correct here. Yay! We are correct. He is twice or 2 times taller than Derek. I'll hit next and I'll clean off the board. Let's do it again. Ziggy has 5 dog toys. His sister, Angel, has 25 dog toys. How many times more toys does Angel have? Wow. The first set of numbers is 5, the second set of numbers is 25. The unknown is how many times more toys Angel has than Ziggy. So Ziggy, poor little Ziggy, only has 5 toys. Angel over here is sitting pretty with 25 toys. We have to multiply this by something, by some variable. Right now I'm just going to do a blank line, all right, to equal 25. Some of you know your math facts and you're like, I already know this answer, Ms. Farmer, and you're screaming at me through the screen, and that's okay. Some of you are not quite so sure. 5 times something equals 25. Let's read the options. Angel and Ziggy have the same number of toys. 5 and 25. Is that the same number? Definitely not. No, can't be right. Angel has twice as many toys as Ziggy. Well, if it was twice as many, it would be times 2. So let's try that. 5 times 2 equals 10. Is that 25? Nope. All right. Angel has 3 times as many toys as Ziggy. All right, well, let's try 3 times. 5 times 3 equals, is that 25? Nope. Angel has 4 times as many toys as Ziggy. All right, well, let's try 4. Nope. Angel has 5 times as many toys as Ziggy's. Well, let's hope this one's right because it's our last option, and so far everything else has been wrong. Oops. Oh my goodness, it's right! Woo! Party time! This farmer's crazy, but it's right. Alright? Alright. So that one was correct. Let's double check that we weren't crazy. Just a little crazy. Like that, we got it right again! Once you have the equation, doing the answers is pretty simple. Once you get the answers right, once you know what the equation is, you know your knowns and your unknown, plugging in answers doesn't seem to be too hard for you guys. Again, have any questions? Stop and contact me. I'm available. Now I'm gonna send you to your activity. So you're gonna close out of your YouTube tab, go back to your Seesaw tab at the top. You're just gonna go right back to Seesaw. Complete the rest of the lessons in this activity, the practice, and then you're gonna go back to Accelerate at the very last slide of Seesaw, and it'll take you to your quiz. All right? Any questions, comments, or concerns? Remember, this whole lesson was parts of a word problem, which means your quiz is going to be parts of a word problem quiz. It's very, very, very tricky, okay? Parts of a word problem quiz. All right, see you guys later. Bye.